Hi everyone, I welcome you all to our session. And this session will be very much interesting as we are going to talk about that how actually servers have evolved from running into data center to managing on a public cloud. And this session will be taken by Tarun, who is currently the lead DevOps at ABB. So, without taking much time, as we all know that yes, Tarun is an amazing speaker and also a contributor to Azure. So, with that note, without taking much time, Tarun, the stage is all yours, and we can start with the session.
Thank you. Thanks, Chavi, for that wonderful introduction. Good evening, all. And we are here in the weekend evening to learn something around how the evolution of servers from data center to managing on public cloud. So I am basically working. I started my career as a system admin when I specifically chose this topic because I have seen the servers while from working since 2010. Working since in the on-premise typical data centers, in the private data centers that were when public cloud was not much into picture. I think apart from AWS, there were no public clouds when I started my career. So probably I have seen that phase where we used to go to the data centers and do a like monthly visit. We used to perform at least one monthly visit to the data center and see if there are any glitches for the servers which are hosted in the data centers. So I've seen. So I think that's why I've chose this topic, so that it will be a refresher for me as well, and even for the folks who are joining this would also get to know some of the insights how the things have evolved from the typical on-premise data centers to the cloud ones. And yeah, so this is the topic for today, and it will be going just moving on to the next slide. So we would be moving to the agenda, right? Although this typically this half an hour is too less for me if I have to talk on this topic, and because starting from a system admin towards the now acting now as a cloud and DevOps practitioner, so been seen that journey of last around 12 years. I've seen that journey how the mostly because this is one of the topic where because I'm mostly have, working in the infrastructure side, and now it has been also the infrastructure has been converted into the cloud and DevOps as well. So this is the topic which I actually selected because it describes my journey as well, like how the things have evolved over the course of time. So when I say on the agenda. So first we will discuss on the history of the data centers, how it got evolved, data center components, and then we go for the evolution of the virtualization concept when it got invented, and then the virtualization concept as in we will try to understand what is the concept regarding, and then the advent of virtual machines, like what after the virtualization concept came, then the came virtual machines, and we will go through the converged and hyper converged infrastructure. Typically we call that as a hyper V. You might have heard about this hyper V and all those things. We'll understand what those terminologies are in a brief, and then we will go to the timeline. I have just kind of prepared one kind of timeline how the data centers have evolved over time, starting from the early 1990s to till date, till so these 35 years how it been. And before to that also, how this concept of virtualization came. It came much early that we will discuss, and then the nutshell and summary until this concept of public clouds came into the picture, where I think Amazon was the first one to host their data centers in regions and data centers like around 2006 2007. During that point, data centers was acquired by a lot of public clouds. First was of course then in there we started the concept of hybrid model, while some of the data center servers of the companies will turn in their private cloud. Private cloud means the cloud which is pertaining to that organization, and the public cloud, that first introduction came for the Amazon is come around 2006 7, when they first hosted their region in the US. And then how it got, we are dealing with the hybrid world right now. Like for half of the infrastructure of the company is in public cloud, and half is in still the on-premise private data centers. And then came the shared responsibility model. Like that's where we enter the public and the hybrid cloud model, which I just discussed of brief in a while. And then we go through the differences which I've taken to explain all this, and then in the last we will take in the Q&A. So this is basically a conceptual kind of short discussion which I've just scheduled to get to know about it could be the starting point of your any cloud journey which you choose, which can be Microsoft Azure, it could be Amazon AWS, or it could be Google Cloud, because this is the beginning. After that, the public cloud came into the picture, and then the fundamentals concept came after this shared responsive model came. So then from there on, the journey of all the cloud fundamentals got started. So this is the originality of all the things which we are doing in the IT world. So history, like over the so basically, as it's a conceptualized, I will try to represent some of the things through the theory. And most of them I have tried to prepare for 5 6 slides. I've tried to prepare it on the covering some graphics as well, so that the images, so that you get to know the concepts more easily and understand. So over the years, like, data centers have evolved themselves into the physical as well as the virtual infrastructure. Physical means the data center which are there in the private data centers, like the rack servers or the blade servers. When I started, I have seen both of them. So rack servers was the horizontal one, and the blade servers was the vertical ones. So they were kept inside the chamber of data center, which were enclosed. Typically we have to check the cooling as well, where the AC was also there, and we have to check the network cables and all those things, managed properly, network cables, and proper lighting, and proper cooling and ventilation for the servers, because when the physical data centers were running, they used to generate a lot of heat inside the data centers. So this was then comes the third point which I mentioned. So earlier the data center struggle. This was a struggle period which I have seen. Cooling system, power supply. Even I think I think 5 years back, where there was one region which when I practically in the production system I saw it in US, when there was no that the Azure region failover, like, which is called, the term is called the zone redundancy. Like like there's a concept of in Azure called the where we fail over to in the same region. There are different data centers. In, for example, in US, there should be in the same US there could be three data center availability zones. Yeah. So there was no concept of availability zones in that particular region where our servers were hosted. So what happened was, due to the cooling system which got disrupted, our entire production system of that particular region was down. Thankfully, our application was hosted in all the global regions, which was American, Europe, and APAC. So it used the other data centers used to handle the traffic. So when this happened, so this struggle used to come up, and then the from here the concept of the availability zones come into the picture, that we will discuss quite later. So this is like earlier data centers struggle with infrastructure hassles, like power supply, cooling, cables, the network cables should be like not lying here and there. It should be properly structured, and and then it should be placed. It should be well placed inside the servers through the back cables. And lack of mobility, with these heavy servers, you can't move here and there your infrastructure. It was really impossible. The load of the rack, the particular rack which are there actually the data center is very very heavy actually. So it's not possible for you to move the things here and there. So but now the most of the major concern around the speed, performance and efficiency have been addressed with the advent of the cloud. So and the third thing is like now which is happening is like most of the enterprises are using the hybrid cloud to take advantage, which are taking both the on-premise as well as the public. So this is some of the history, and we will see, we go through some of the data center components next. So which is like the three things which are necessary for any service, the server, storage and networking. Basically the you could also say that when you say server, compute, so compute, storage and networking. So always these are the three pillars for any any to start of the any in the data center as well. The server, when it means like the evolution. It's a very most important component of a server computer. The and the evolution of CPU is based on number of cores it represents. So when we started working inside the data center, it was started from the single core, where single core CPU we used to handle so much of workloads, and then it came the dual core, and then now we are working in the multi core, and also in the we have evolved from that particular architecture to the virtual machine, and then to the containerized world, and then now we are into the serverless as well. So this is how things have evolved from a server perspective. I started working from single core CPU, and I've seen that journey how it had been evolved from a single core to dual core. A dual core used to come in the laptops. Laptops were too expensive when it came into that particular time, and then the even the my laptop which is currently I'm having, it's a multi-core. So this is how the server journey got started. Storage, again, storage started from a 1.4 MB floppy, which is now converted into a 30 TB SSD. Like how these are coming, the technology which has evolved from the IDE to SSI, SAS, SATA, and PATA to today to NVM, which is non-volatile memory express. Non-volatile memory we have seen which are coming up, which are we can scale those storage as well. Then comes the network cables, which have started. We have seen speed coming from 10 Mbps. Now it's been evolving to 100 Gbps. So this is how the switch and how the devices from the typical bulky hubs and switches routers has been converted into very thin client LAN, Wi-Fi or line Wi-Fi or 3G. Even in our, if I say about the robotics, we are very thin clients have came up for connecting the devices, because it's all about connecting the different things in the inside the robotics. So then now the server, storage and networking, how these are the some of the components which are there. And now this is the fourth component, which is from this things, these things have been changed to the virtualization. Then this is the first step after the data centers, first step towards the advent of the new technologies. And virtualization, it was the starting point, for from hosting multiple servers for one when we used to work, we used to have in one particular no the rack server, we used to have one application running which comprised of the application database, and in the other rack server there was different application running. So to avoid this concept of virtualization came, wherein in one particular rack server we used to install multiple applications, run multiple OS, and in one OS we so we VM used to distribute the different operating systems. And then this concept of virtualization came, where and then later when we see the hypervisor, we will see how with the use of hypervisor with a single host, we could run different different VMs, like acting as now it has been same concept has been converted into the containers, inside a single host we are running different applications, which is comprising of the application as well as the databases. So in virtualization, um, these are the discrete components where we are playing the vital role. And then came in this era of virtualization. So in the virtualization, as you could see, the physical components were divided into three logical components, which was into logical components and then represented to an application using the multiple physical components. Like we had a shell, kernel, and hardware. So hardware was typical your Intel, and kernel was the basically the nervous system of and hardware consider hardware is the kernel as the nervous system, and the shell as the the remaining part of the functioning. So this is how like the outside, how it used to interact to the outside world. So this is how the evolution started, like hardware, kernel, and then the shell. So with the advent, if you can see the flow, a user used to interact with the shell, which is the outside, the outside environment, and then it used to interact with the kernel, and then the kernel used to interact with the underlying hardware. So because hardware was always necessary to move this, the basics of the evolution of virtualization still remain the same. It started from the hardware, kernel, shell, and then the user. So user used to interact directly with the shell environment. Any user would interact with the shell, and then the kernel where will give the information regarding regarding the OS version and the patches which has been updated in the OS version, and the hardware will give the information like this OS installed in this particular hardware, which is Intel or anything, and then it will be connected towards they are interconnected, and then it will be connected through the networking cable to Cisco routers or anything which is coming into the picture. So this is the virtualization which is came. Now this, but basically before going to the timeline, the concept of virtualization came much early. It came in the late 1960s and early 1970s when IBM was the first, invested a lot of time effort in developing the robust time sharing solution. But if you remember, see the history of the IBM, the first hard disk of I think the 2 MB, it was huge one, which is came the pen drive, which we now have a chip also, which is coming via plug-in in. So that IBM was the first one to introduce the concept of virtualization. Typically, they started with a lot of computers connected with each other in a particular room, and then there are different room where different set of computers were connected. So multiple like 10-15 computers connect to a network. They called it as a data center. So they started evolving. They worked on this, and this was started much early, which is early 1970s when IBM introduced this concept of virtualization. Now the other thing which how the from virtualization came the concept of virtual machine. So because we are talking about hardware, kernel, and the user, which forms the basics. Now a virtual machine comprised of there used to be a physical server which is used to handle the hardware, CPU, RAM, input output, the networking, and then came the hypervisor. We will see the middle layer, which is came between the physical server and the virtual machine. So over top of physical server, like consider this a rack server, it's a horizontal one. On top of this, we used to have multiple virtual machines. We used to hypervisor was acting as a platform, right? When hypervisor, it was necessary to host the different to 4, 5, or 8, 10 virtual machines on top of the hypervisor. So hypervisor was a technology which was used to, as I mentioned, right, previously we used to have one server and application in one rack server, like but this gradually. But when I started my journey towards my in my career, hypervisor was still in place around 2010-11. So hypervisor was a necessary component where we could virtualize the physical server to multiple virtual machines. So that was possible with the advent of hypervisor. So a single computer can play multiple. So this is a single computer which can playing the multiple operating system, and all operating system boot at the same time as a virtual machine. So we can use multiple virtual machines. We can use install 2 3 virtual machines on top of hypervisor. But again, that hypervisor had a limit depending upon your physical server. If it's a dual core, we could use allocate one CPU to this virtual machine, one CPU to this virtual machine. It all depended on the number of cores which the physical server is having. So upon depending on that, we used to install different kind of virtual machines on top of the hypervisor, and then all virtual machines run and an application on single kernel called hypervisor. So this is a single kernel. I explained the previous slide, right? So kernel was supposed to be the user goes to the traffic used to come to the virtual machine. So the front end consider virtual machine as the user will come interact with the virtual machine. A typical load balancer, consider there's a load balancer above this virtual machine. He won't get the IP details of the virtual machines, which virtual machine is interacting, but the application is hosted in both the machines. So he will be interacting with the typical load balancer, and then the traffic will be routed to any of the load balance virtual machines, and then this is the user interaction. And the hypervisor used to act is acting as a kernel. And then we had one more. The hardware is the physical server. So this is how I've mentioned the second point. Hypervisor was acting as a kernel, and then a set of virtual machines from the cluster. So when two or more machines combine together. Similarly, the concept is there in the containerized world as well, in the Kubernetes and the orchestration engine. So when two or more virtual machines are there, then it forms a cluster, and it serves as a single service. So it load balance, typically an application consider this as an application load balance into the two VMs, and it is load balancing the solution. If you need at least two virtual machines to load balance a solution and go for high availability. And then this single storage disk shared across multiple servers from the cluster storage cluster. So what used to happen is app and OS used to be installed in a virtual machine, and I talked about, for example, this physical server is having two cores. So this memory used to be shared with two virtual machines. This is the concept of hypervisor. The memory would be shared with the two virtual machines. So you need to allocate the memory and all those parameter RAM accordingly, according to the cores and the RAMs of the hardware. You used to allocate those things into the virtual machines, but that was all physical. We used to set these parameters in while going into inside the physical server inside the data center. We used to do a typical, you can see that, if I give an example, we used to do that. You do a when you give receive a new laptop, you only receive C drive, right? Manually you will partition the device still. So this is how we used to do during the time of around 2010. We used to split the RAM and the CPU according to the physical server, and allocate to create the virtual machines according to it, and install the OS on top of it. This is, I think, as I could recollect, this is how we used to do splitting. That all, it was manual, it was not auto scale, and it was not managed by any cloud vendor. It was typical on premise, which we used to go to data centers and do that. Or someone should have the access of the physical server. If not, then we used to go to a data center to see. If we are not able to access physical server, then we used to have to go to the physical site and see. But now with the advent of cloud, this all has gone. So I will go and see the difficult aspects of it. Now the came with the concept of the hypervisor. We will go a little detail about the hypervisor concept, how it evolved. Like, if I given some basic things on the hypervisor, but this is a little detailed things on the converged infrastructure. Um, Chavi, any questions till now? Because then this is a very important topic. Before, if I have any doubt, then I think won't be able to understand. So until this point, I think I will take a pause, and please let me know if any doubts, any questions. Okay, I think. Okay, I think. Yeah, there are no questions as such. Okay, okay, then I think I will go on with the converged infrastructure. Um, so converged infrastructure came in the converged infrastructure. So if you see the virtual machines, application and services, then came the server virtualization, the vSphere or the Hyper-V, and the physical networks. You can see the network configuration, compute configuration. This is how physical storage used to happen. These were called the racks, the blade servers, the vertical ones, and the the thin the thick lines were called the horizontal one were called the rack servers. So this was the typical servers which was there in the data centers. The idea of component virtualization, the integration and management gave rise to the term called converged infrastructure, or CI. Like where we the idea of component virtualization, this virtualization concept and the integration and management with different layers like networking, compute, storage, and with the interaction with all these things, we referred the term as converged infrastructure, or CI. So in converged infrastructure, the various components are grouped together to form a single CI node. Consider this a single CI node, where how this is in the physical in storage was like a typical storage devices, and then the compute we had servers, the thick clients, and then to interact we had the routers. So consider this management of can be considered a single CI node, where it's serving as a which we call in typical architecture as a single node cluster. So this is how it used to be managed when it was there in the typical data center: storage and the physical compute, thick lines, and then the network configuration, the firewall routers, and then the vSphere client, which is called the hypervisor. And on top of it, we used to install again, on the type of virtualization, we used to install a lot of VMs, and split that memory or CPU according to the virtual machines we had to install. The core, for example, it's a dual core, or um, it depends on the physical the compute servers, how much memory and RAM it has. Then we used to allocate the virtual machines accordingly, whether two or four or six can be created. So that's what it's considered a single CI node. So the data center administration gets a single management utility interface to manage all the components of CI. So this is how it was very difficult to manage then the physical infrastructure, that is converged infrastructure, which is called. So then that came the concept of hyper converged infrastructure. And hyper converged infrastructure, again, it evolved from then came the era of software defined components, where we used to have storage and networking clubbed together to form a hyper converged. In the converged, this all different layer playing different parts. But here now we will come into the picture where we will have software defined networks, software defined storage, and software defined compute, which when form software defined infrastructure. So this particular term software defined implies that the service expected out of physical devices were getting programmed, so and the performed piece of code running on a single node. So what used to happen is the uh, the services, for example, one web application, .NET application, which is running in a physical server, it was programmed to run, and firewall used to be opened. So all functionality we used to club the servers started to come with the inbuilt storage, not with the so the con- with con- as in opposite to the converged infrastructure, all things were coming inside the storage array itself. The storage array used to consist of the servers, the RAM, the basically the disk, and the network, the Ethernet ports. It used to came in one particular server. So this called hyper converged. Programmatically, we used to. That's how server started to come up started from a single devices. Now it used to offer functionality in a compact device system, that is called hyper converged infrastructure. So this is the definition of hyper converged. So and then this is the typical summary where we used to call we call hyper converged infrastructure as sometimes we call HCI. HCI, like as you said, hyper-converged infrastructure is all the programs of a discrete component are clubbed together to form a single HCI node. As you can see, the network, storage, fiber cables, and the servers, these are non-converged in the previous example, which is converged infrastructure. So then comes the converged, that non-converged got converted into converged, where we used to have server, network, and storage, converged infrastructure. Non-converged is the where we used to have different things. We used to have storage, a separate storage server, separate file share server, and then thick network switches were there in the data centers, and then the servers. This was called non-converged. Converged this is called got compact, and the network and storage switch used to come in a single device, where the network routers you also used to offer storage as well. And then this particular got converted into hyper converged, means all the functionality, storage, server, networking, and disk, all used to come in one, and it got converged, hyper converged. So how this is how the servers technology got compact. And this is how these are some of the components which were there when we talk about the data centers. So as the components are software defined and integrated together in a node, managing them through an external interface, now this is easy, right? When we have to deal with an infrastructure which is hyper converged, it is easy. And what was still difficult was the scaling in and scaling out. So scaling in, scaling out, we still if there's a load increase, we can't do that, we have to procure more VMs. But still, this was the challenges. This was addressed by the introduction of the cloud things, the cloud. So this is one of the timeline with how the things got evolved and changed. In the pre 90s, data centers were formed. Like I said, that the virtualization still 70s, and in 70s, IBM was the first contender to do that. Data centers were formed using large rooms of computer, where computer bugs indicated live bugs inside these large systems. Um, so basically, there are a set of computers connected in a single room, and then in a separate room there were a set of computers in a different room performing different computations. So this is how the data center started. And in around 1990 to 2000, during this decade, as internet and client server computing started getting staged, so client server concept came into the picture during this time, and data center became more reputed and drastic for growing businesses. Companies started adopting their own data centers. And then came in 2000, 2007. This is when the 21st century began, and then technology was reaching unprecedented heights. Major improvements like data center services, data center outsourcing demands, and the sharing hosting coupled and with the application hosting, managed services like ISPs, ASPs, MSPs, etc. came into the light. So and this was the time when we started seeing the uh, you know uh, uh, huge benefits in terms of having companies started adopting their own data centers, own infrastructure, setting up their own private infrastructure of their they used to buy a subscription inside the data centers, and they a monthly yearly billing purchase order used to happen, where billing used to happen like how many servers, physical servers you are hosting in for your company in that particular data center. This is how even I have worked on this one. So 2006 7, when it I think Amazon came into the picture, they started with their regions, their data centers, hosting their public clouds into the when it started with 2 3 regions initially. So 2006 7, so this is how public cloud also came into the picture. And now 8 to 11 was the time when even the I think the Microsoft Azure and Google cloud also came into the picture. So in this time, this period, data center became more stabilized, and hence was focus shifted from the power efficiency, cooling, and management facilities of the data centers to modernizing the infrastructure. The modern society gave a lot of choices while planning to set up the data storage system. Means a lot of choices came. The hybrid infrastructure also came. People used to host 50-50 to reduce the cost, because physical hosting, raising a purchase order used to be very costly. So for example, if company is running 10 servers, now what is happening, 5 servers are being hosted in the on-premise, and five, or which is their private data center, and 5 in the cloud, just to save some cost. Because with the advent of cloud, it came the concept of pay as you go. Like you pay only for what you use. So lot of we started see lot of drastic changes in terms of doing that. Now we are living in 2023, where we are seeing with this post pandemic era, we are seeing more and more technologies moving towards the cloud. So that is where the to reduce the cost, even the startups and all those things are using the technologies. They're starting directly from the PaaS services. So no one wants to go to the service things like this IaaS. So we'll come to that as well, which is called shared responsibility model. So this is the timeline how it has evolved till now. So yeah, in a nutshell, providers are switching to independent data centers in recent years, and henceforth the evolution of data centers is expected to take a new height. Workloads like big data analytics, machine learning, AI, and IoT, and high-end technology are changing the focus of the data centers. So now comes the shared responsibility model, which is very important one. This is because this is the introduction. Because from we have started from the servers, we have started from the non-converged, converged, hyper-converged, and then data centers. And now this was the time after 2010 or 11. Then a lot of cloud vendors, along with Amazon, started um, uh, you know this model came into the picture. This very model came around 2010, if I could remember correctly. And why this model came? This model came to give the flexibility to the to split the responsibility between the user and the cloud. So cloud used to say, hey, you don't bother about the infrastructure needs, you give that flexibility to us, you concentrate on your application and data or the access level, we will manage all those things. So slowly this data center business got trying to shift towards the cloud. And then this shared responsibility model was introduced in 2010, when more all the major cloud vendors came into the picture. So this was the nutshell. This responsibility got shared. So the people now used to and now we are so see how things have evolved from from managing IaaS, PaaS, and SaaS. Now we are moving towards the containers and serverless. This is the time which we are living in right now. So this is like this concept came. And starting with the traditional corporate data center, the company is responsible for maintaining a physical space, ensuring security, maintaining. So this was the case you saw, right, in traditional corporate data center. Company to whom you have authorized to maintain your servers, they used to manage the physical space. They used to manage the security as well. A lot of cost was involved in that when we used to raise a purchase order. With the shared responsibility model, this responsibility gets shared between the cloud provider and the consumer. So physical security, cooling power, you don't network, you don't have to bother anything. Now, if anything goes down, it's the responsibility of the cloud vendor to look into those things. So this is how the paradigm shift happened from the servers running in the traditional corporate data center to the cloud one. So this is how the advent started. So around 2010, 11, and with this model, this came into the picture, which we will just describe a little. So till this time, any questions? Let me check as well. Okay, if you, sir, please could you guide me how are we connecting hypervised convert data with the cloud? So yeah, hyperconverged data centers with the cloud. It is like the typical the IaaS based model, which is we are going to discuss now. It actually deals the servers which are there actually are already integrated with the Hyper-V client. Hyper-V, this particular things we don't have to manage. This has been taken care. This is where I'm coming to now in the shared responsive model. From when we started uh, when I started my career, we used to the server used to have the Hyper-V already installed in it, and on top of it we need to split the, according to the physical server requirement, we need to split the RAM cores, and only those many VMs we could create according to the physical server capacity, and we can't exceed that. So this was managed by the hypervisor was there. That's why we were used to split the VMs according to the size of the underlying physical server. So but now when the cloud came into the picture, we don't have to manage these things. This is managed by a team which is generally referred as cloud hostings by the organization. They will take care, even in the typical IaaS environment, infrastructure as a service, they will take care of all these Hyper-V clients. all the VMs or virtual machines, the IS based computing engines are coming as a Hyper-V client. So we don't have to bother about those things. We can just start our journey with creating a VM, and we can take a complete control when we start with the IIS model. So this Hyper-V and all comes into the hardware part, and how the machines are being managed by the cloud vendor. So this now we with the from shifting from the non-converged, then hyper-converged, non-converged, converged, and hyper-converged. Now we are shifting towards the shared model. Then the shared model, we don't have to bother about the hyper-convergence integration with the cloud, because this has already been taken care in the model itself by the cloud vendor. So that's what I will explain now. Actually, uh, when this shared responsibility model came, so what used to happen, responsibility, this is first is like responsibility is always retained by the customer. This will all be retained by customer. These are set of responsibilities: information and data, device, accounts, identity, application, network, controls, operating system, physical host, physical network, and physical data centers. So these were the responsibilities. Now coming to the SaaS, PaaS, IaaS, and on-premise. So we started with on-premise, right? This all things, for the rightmost, we started from this on-premise. So this it was typically the headache of the customer. They used to manage all these things. If and the first raise a purchase order, buy a physical host in the data center, and even the operating system there, they were using network controls also. They were supposed to check. So it was all the responsibility of the private data centers to do that. And it was again because the customer has selected that particular private data center. Like for example, I went in one of the, I think, data centers in Tulip data center in back in Delhi in those days. So we used to raise the purchase order, and then we used to host the data center. So a lot of data center, like we have Airtel as well. So we used to go, and typically all things were managed by the customer itself by purchasing the by raising the purchase order. They used to buy the machine. Now came the IS, with the infrastructure as a service. So the all things like Hyper-V and all those things, we did. So it here I've shown the Microsoft. It could be any cloud vendor. So all this physical host, networking, data center, all used to be handled by the cloud vendor. So a virtual machine which you typically create today in your portal, Azure portal, or AWS, Amazon instance, it is being handled by the Amazon or the cloud Azure provider. So the cloud provider basically. And the operating system, again, what operating system you are installing, right, at the time of version creation, like Red Hat, like Linux or Windows, it is your choice. It With the IS, you have complete control of the operating system virtual machine, but the physical assets, including the Hyper-V concept which I have explained, it is not your headache. It is again the cloud vendor. So it starts from here, so that at least you can start focusing from the OS, network controls, like firewalls, and the application, and these all things are managed by the customers. So this is now the if I come to towards this model, right, this will always be under the control of the cloud vendor, physical host, physical network, and physical data centers, when it comes to the IS, PaaS, and SaaS. And then comes the PaaS model, which is, I think, the most of the applications which are running now are mostly on the PaaS. Means the cloud vendor, even they will manage the operating system as well, and this network controlling application will be, and the entity will be 50-50. Like the customer will manage half of it, and the cloud vendor will manage half of it. So this is like the responsibility will be shared. So this is how most of the applications are in PaaS, like the Windows, the the app services, web app services. These are all the example of PaaS: the Cosmos DB, the Azure SQL server, the managed one, and the Kubernetes, and all the containers. These are all the concept of the PaaS. So the only that you have to only bother about your data, the access, to whom you want to give, and the application control. This is all 50-50 managed. And then there came the concept of SaaS, which is completely the basically is completely up to the customer. For example, Facebook or Gmail. So they you have your own account, right? And information data which you are putting, it's coming in the social media handles. So the entity is being controlled by you. So only the minimum information, and all these application like are being controlled by the cloud, or the the vendor who is handling all these things. For example, Netflix example is stored, is hosted on Amazon. So the Amazon is handling all the application, it's handling the all the things, and Netflix is handling their information data, website, the application also, and the infrastructure and the accounts also, which has been managed by Netflix. So this is how all these things are coming into the picture. So this is how the responsibility got trying to shift. So responsibility, then responsibility by type, this is the responsibility by type, and then responsibility always retained by customer. So the data devices through which, like mobile or laptop, you are logged into Facebook, it's always be under your control, and information data will be always under the customer control. And accounts and entities again will be always the responsibility of the customer. And responsibility then, according to the three models, this is varied according to the type. And then this will always be with the cloud. In the on-premise data centers, you don't have to manage all these things. So this is the the paradigm shift which has happened over the years, from on-premise to data centers to the IaaS or PaaS or SaaS. Even the data centers are still there in the all the three scenarios, but you don't have to manage all these things in the from the typical physical servers. You don't have to manage and deal with all these things. You can concentrate starting from operating system, and in the advanced use cases, even though that too you have to concentrate 50-50. You can avoid that one pass. So yeah, so IaaS, the VM or storage, and all these things, a virtual machine are the example of the IaaS. And the SQL Server installed on a VM, that is also an example of the IaaS one. And on-premise, which we already saw. So I think this is the physical, the some of the summary. You will be always responsible for, you means the customer, the information data which you are storing, the device through which you are logging in, the accounts and entities to whom you want to provide the access to the application. And the cloud vendor will always be responsible for the physical data center, network, physical host. Because after this cloud came into the picture, I think no one, anyone from us has gone to the data center. So yeah, fortunately, when I started, I got a chance to do that, and I have explored this journey altogether. So, but nowadays, I think it's very limited since last 8-9 years. So it's all been managed. Why? Because it's all been managed by cloud. And then how this your service model will then again will determine responsibility for things like operating system, network controls, application entities. So this, according to the model you choose, IS pass, this will be splitted. The responsibility will be splitted accordingly. Then I think these are some of the references, and I think that's where I just want to quickly, yeah, that's what I just wanted to present. And any questions apart from the one which I hope so I have tried to answer that, Harsh. I don't see any questions. I think Chavi, I am done. I have taken little few minutes extra, but I think I'm
Yeah,
committing
that's
now.
great. Actually, there's no other question, and I guess the yeah, Harshvardhan also loved the reply, so it was great. So with that note, thank you so much, Tarun, for joining in today. It was a very
Thank you.
insightful session. We talked about a lot of stuff indeed. So thank you so much, and thanks so much everyone for joining in.
Thank you, Chavi. Thank you all.
Yeah, thank you. Have a good day. Bye.
Thank you.